First of all, good afternoon, everyone. And thank you very much for joining us today for our fifth presentation in the series of our reservoir engineering technical sessions that we currently are hosting for all our clients in SSA. So what we'll be talking about today is reservoir engineering in DELFI. All right, so I'll just give you some insights into the technology as well as services, right, and solutions that you as a reservoir engineer can access in our DELFI environment. So my name is Ndivhuwo Nemakonde, and I'm a reservoir engineer based in Cape Town. And alongside me will be Henio Alberto, who is our reservoir engineer technical consultant, and he is based in Luanda. So what Henio will do is take us through the demo, right? Showing you all the features and, you know, the cool things that I'll be presenting on today in these slides. So I hope that you'll find that interesting. So this is the agenda that I'll be following for this afternoon's session. So I'll just start off by sharing with you what our vision is with regards to reservoir engineering in DELFI. I'll then also give you an overview, okay, into what DELFI is, because as much as I'm sure most of you have heard of it, it may still be a little bit vague exactly what this platform is, what you can expect to do, right, and what we offer. So I'll just try and give a little bit of clarity on that on a high level. Thereafter, I'll speak to you about the reservoir engineering ecosystem in DELFI. And I'll also accompany that with the different technologies that we currently have. I mean, this is not exhaustive, but for the sake of this presentation, I'll focus specifically on the Petrotechnical suite. I'll speak on reservoir simulation, which is abbreviated ODRS. And I will conclude by just sharing with you about the reservoir engineering workspace, right, as well as the different elements that constitute it. And after this presentation, we'll then go on to the demo and we'll open up the floor for some questions. I mean, if at any point during the presentation you may have any questions, please feel free to leave them in the chat, and somebody might respond to you, or we can wait till the end of the presentation to have a discussion around it. So our vision in for reservoir engineering in DELFI is basically to enable faster and high quality reservoir informed decisions. And I mean, this is of course in alignment with the needs of our industry today, right? I mean, what we're looking for is a way for us to be able to achieve solutions very quickly, as well as making sure that we do not compromise on the quality, right, of the work that we're doing, right, or the decisions that we are making. So how are we addressing this? How are we making the solution faster, right? So the first way to do this is to provide you with a scalable, concurrent, high performance computing environment, right? And what I mean by that is that within DELFI, you will have available to you or at your disposal an unlimited amount of hardware as well as software resources that you need to perform the work that you want to complete, right? So you will not be limited by any hardware constraints or software constraints. So the second way we aim to achieve this is by providing you with a system that is based on artificial intelligence, right? And essentially what this will do is provide you with recommendations on how to best do your work, right? It'll give you suggestions regarding the best way to structure, for example, your field development plan, the best location to drill your well as well. And I mean, this is very similar to a lot of the AI functionalities we've seen, right, in, for example, Microsoft PowerPoint. I mean, if you're creating a PowerPoint, you will get a bit of guidance regarding how to structure, the entire slide. So essentially, this is what we'll also be doing. We'll be giving you guidance. And the whole aim of this is to help you speed up the decisions that you need to make, right, overall around your asset. So thirdly, how we aim to do this is by bridging the gap between the domains as well as the decision-making processes that you need to deal with, right? And when I speak of higher quality, what we aim to do is to enable you as the user to be able to properly and thoroughly quantify the uncertainty associated with your subsurface, with your field development plans, or whatever it is that you are currently working on, right? Because I mean, gone are the days of us using the deterministic approach, to doing our work. So it's important for us to understand the risk associated with whatever it is that we will be doing. Now, the good thing about Delphi is that it provides us with the environment, right? And not only that, but the tools for you to be able to perform this uncertainty quantification. So what we also aim to do, and are actually currently doing, because as you know, Schlumberger as a service company is very serious about providing you with the best technology and science, right? And the same applies to the software that we provide to you as a client, right? So we have best-in-class science across all the different domains, right? And I mean, this is reflected, also in the software that you're currently using, right, in your locations. I mean, if you think of Intersect, it's a software that is next generation when we speak about reservoir simulation, right? And it's able to handle complex environments, complicated physics, as well as, very complex field development schemes. So we have added this into Delphi, right? And it's also elevated thus on the cloud. And lastly, what we also aim to do is to have you connect to the data that you need to make meaningful decisions. Okay, and all of this is available in Delphi for you. So let me just give you a bit of an overview of what Delphi is. So in short, Delphi is the cognitive E&P is a cognitive E&P environment, right? It is highly scalable, it's highly secure, so you can use it confidently knowing that your data security and privacy is intact, right? And it is also a solution that is open and extensible, right? So if you wish to connect it to your external environment, suppose that you have software that you've developed internally that you use, right? And you want to connect this to Delphi, you are able to do so using various APIs that will enable you to will enable to have that happen. So Delphi basically provides an extensive set of E&P software solutions, which help deliver integration and connectivity, across all the different subsurface domains, right, as well as midstream, right? So geoscientists, reservoir engineers, drilling engineers, production engineers are able to collaborate in this environment, right, and share ideas as well as insights which will help enhance and enrich your workflow. So what Delphi also does is that it brings together advances in the technical disciplines of artificial intelligence, machine learning, as well as automation, right? And these are the tools that actually add the value, right? So they enable you to edify these workflows through the suggestions that you get from the environment. Delphi is available to you on or rather as a software subscription as a service, software as a service, model, which is fully managed by Schlumberger, right? So you don't have to worry about installing anything, upgrading anything, or setting up anything manually, right? So everything is fully managed and available for you. Literally, all you have to do is to just have a subscription to the services that you want to use, right? And based on your profile, you're able to log in and access that and to continue doing your work as you need to do. So what you'll see in the middle of the screen is a big box, which has the writing data ecosystem, right? And this is basically the heart of Delphi, right? So this is where all the data that you'll be using, should you be working on the cloud, is stored, right? So this data comes from multiple sources, such as our applications, our software applications. It could come from third-party applications, data being read from servers in the field, as well as various databases, right? So on this data ecosystem, we have a stack of technology, right? And I'll just take you through that quickly, just so that you understand. The first is, of course, our Petrotechnical suite, which is this little box that I have up here on the left-hand side. So the Petrotechnical suite actually is a collection of all our traditional software, which I'm sure most of you are fully familiar with and have installed in your computers, right? So I'm speaking of Petrel, Studio, Avostate, etc., etc. Right? So all of this you're able to access just via logging into Delphi and opening it up as though it were Petrel in your computer, without having to worry about what licenses you need, right? Because all of that will be available for you to finish up your workflows. So the Petrotechnical suite also connects very seamlessly to our high performance environment, right? Which is where you can expect to use our simulators, right? So the simulators I speak of are basically your Eclipse, Intersect, Geoframe, etc., right? So when you want to run simulations in the Petrotechnical suite, you're able to launch them into these simulators, right? And depending on how many hardware resources that you need, and what I mean by that is parallel scalability or coarser processors, right? You're able to access as many as you want, right? And this is good because, I mean, the more processors you use, the quicker your simulations will run, and the quicker you'll be able to finish your projects, and the quicker you'll be able to make decisions. Now, in addition to this, we have some native Delphi applications, which are, for example, your drill plan, there's PodOps, we have FD plan, and all of these integrate with the Petrotechnical suite as well as the high performance environment. So all of these tools work together, and you're not going to be working in silos like we do now with the software individually installed in your computer. I mean, Delphi, as I had hinted before, is a lot more than high performance computing, right? I mean, what we're doing is that we've developed, and we also still currently developing for Delphi a series of new applications that are tightly integrated with these traditional software applications, right? And the whole purpose of this is to transform the way you work, right? So what I'm referring to here is artificial intelligence, as well as machine learning. So, for example, when you're performing your workflows, this AI functionality can give you recommendations, such as, for example, guiding you in terms of where the best place in your model is for you to drill a well, right? So this will happen in the form of probability map, and you'll be able to identify the sweet spots in your model. And this environment will give suggestions regarding whether or not it's a viable place to drill, right? Another example of this is the fact that, using things like your data analytics, you're able to select the most suitable field development plan for your asset. And as I've also mentioned, Delphi is highly extensible. It is open. So if there's external software that you wish to use within the Delphi environment, you're able to connect that using APIs. So this, in summary, is the Delphi environment. So what does the reservoir engineering ecosystem look like, right? And how does your data flow, okay, as you use Delphi? So your data can be uploaded either manually or automatically, right? Either from the Petrotechnical suite, suppose you're working in Petrel, right? Or from your on-prem installation. So if you have a Petrel model and a Petrel project, you're able to upload that to the cloud. And this will enter into the data ecosystem within Delphi. So, for example, as you're running your simulations, what happens is various services will be activated in the background, right? I mean, you won't be aware of that, but it is happening. And what these services do is they scan your data, right? They scan your models and they extract meaningful information from them. And when they're complete, this data will be indexed and a fingerprint will be created, right? And this will be sent back into the data ecosystem. So in continuation with this, you're able to have that data from the data ecosystem liberated, right? Such that you're able to perform even more workflows using the native data solutions that I spoke about in the previous slide, right? And this, of course, rely heavily on best-in-class science, domain expertise and workflow, as well as AI, right? So once your workflows are complete and you have your solutions, these models will further be sent into your data ecosystem, right? So the more models you send, the more enriched it becomes, right? And the more powerful your AI functionalities will be, right? Because it will pick up the patterns of, what you're doing and how you're working, and better suggestions will be given to you, right? And this process will go on and on and on as you continue to work in Delphi. So these are the services, rather, or technologies that you can expect to take advantage of in Delphi for reservoir engineering. Like I said, it's not exhaustive, but for the sake of the presentation today, I'll be focusing on this. Right. So the first one is the Petrotechnical suite, right? So I mean, I did say before that this is essentially like our traditional software applications, which could be modeling software, analysis software, or even our simulators, right? So you'll be able to access these on the cloud and continue working the very same way you would, like in your computer in the office. You actually won't even feel the difference. And the advantage to this is the fact that you do not have any restrictions, right? I mean, you don't have to worry about whether your computer has the right specs to handle Petrel or whether you have enough processes in your machine to run a particular simulation, right? So all of that is included for you through your subscription. So this service is highly accessible because all you need is internet connection, right? So you can access it from home and you can access it from the office, right? As I mentioned, it links with our high performance computing environment. And what we have there in Delphi for reservoir engineering is the on-demand reservoir simulation. So ODRS, or on-demand reservoir simulation, is a hybrid solution, right? Which we have to help you speed up your simulation runs, right? Or to reduce your simulation time. So this works for both Delphi work. So if, for example, you're working in the Petrotechnical suite, you're able to launch your simulation runs from the cloud within the cloud to ODRS. It also works if you want to, for example, launch simulation runs from Petrel in your computer, right? So suppose that you're working on Petrel, the geoscientist has given you the static model, and you've created your dynamic model, right? Your wells with your designed FDP. Once you're ready to submit your simulations, instead of sending them to your cluster or to your local machine, what you do is you click run and the simulation goes into Delphi. The run will continue there. And I mean, of course, you'll be using as many processes as you want, right? I mean, for example, if you're doing an uncertainty study, you'll be launching a lot of runs, right? So that will require a lot more engines. So once you launch that, your runs will continue in the background, and as soon as the runs are finished, your results will be sent back automatically into your computer, and you'll be able to analyze them the way you normally would if you were to be running Eclipse or Intersect, on your computer. Now, the third piece of the puzzle is the reservoir engineering workspace, right? So this is basically an area where the asset team can collaborate, right? Because it gives you visibility of all the different cases and models and studies that are being performed by each member of the team. So we have two parts to this, right? So the first one is the Reservoir Engineering Data Explorer, and then we also have the analytics side of it. So what the Explorer does is that it helps you manage all your reservoir engineering data, right? So if you've run a lot of cases, I mean, it can be very difficult for you to scroll across and to locate the one that you're particularly looking for. So the Data Explorer actually allows you to interrogate a particular case and identify it, right, and be able to visualize the results. So let's say, for example, you have different FDP schemes. Let's say one is that of water injection, and then in one you are looking into EOR studies, or looking at optimizing your patterns, right? So what happens is you can actually use this to filter down to that particular case, right? Visualize the results and compare it to the results that you've obtained from all the other different FDPs, right? And this is basically how it works. So let's say, for example, you've identified the plan that you're happy with, right? And you want to just analyze the result in more detail. Now, what you'll do is narrow down to that case, of course, using the filtering functionality that the Data Explorer gives. And then you can send it to analytics, right? Which gives you a very, very strong visualization capability, right? So we have a lot of built-in dashboards and templates where you're able to plot your results and analyze them, and basically get satisfaction in terms of whether or not you can improve that FDP better. So just looking again closely at the Petrotechnical suite, as I mentioned, all you have to do is have internet connectivity, and you need to have a subscription or a profile, right? So obviously, depending on what domain you're in, you'll have a profile that will have software that is specific to what you want to do. Okay, I mean, as a reservoir engineer, you'll have Petro RE, you'll have Eclipse, you'll have Intersect, and all the other reservoir engineering tools. So what you'll do is then you go to the Delphi site, log in, and what you'll see is something that looks something similar to this, and it will give you the option to select whatever software you want to use, and it will open up to look something like this. I mean, this is very familiar to everybody. We've seen this before. It's Petrol, right? But in the cloud. Now, the good thing about this, as I've mentioned before, I mean, you don't have to worry about whether or not you don't have a particular license. I mean, think about a scenario where you're doing a near wellbore study and you want to understand the performance around your wellbore, right? So, I mean, to increase the resolution of that, you need to create local grid refinements, right? But if you are working in the office, I mean, you have to first think about whether or not you have that LGR license, right, before setting up the study. And of course, we all know that sometimes creating LGRs may prolong your simulation time. So you also have to bear in mind whether or not you have the hardware resources to be able to handle that, right? So I mean, in Petrotechnical Suite, you don't even have to think about or worry about that because everything you need is already prepackaged and available for you. Okay, so as I mentioned, a lot of different domains make use of this. So we have functionalities for geoscientists, drilling engineers, reservoir engineers, production economics, etc., right, and data management. And as you can see, we have quite a lot of our software technologies enabled already in Delphi for you, right? And obviously, depending on your profile, you'll be able to access them, right? So because this solution is fully managed, right? You don't have to worry about having to, continuously update your software version, right? You don't have to worry about, having to upgrade to Patrol 2020 because it has a feature that you're particularly looking for. I mean, in the past sessions, we're talking about the Reservoir Engineering Extension Suite. And I mean, what you've probably heard is that you need to upgrade your software version to 2018 or 2019 for you to be able to access that functionality, right? But in the Petrotechnical Suite, everything is upgraded for you and you won't even be aware of it because it happens in the background. So you don't have to worry about that. So this Petrotechnical Suite, as I mentioned, integrates with on-demand reservoir simulation, right? Should you need to run simulations. So this works both with the Petrotechnical Suite or with your on-prem Petrol that's installed in your computer. Okay, just to again explain to you how that works. So if you are working in the office or even from home, right? Let's say you have Petrol installed in your computer and you're working from home, what you can do is you can launch your simulation into the cloud, and depending on the nature of your study, right? Depending on the nature of your model, is it complex? Do you need advanced science? You'll be able to make the selection of what simulator you want to use, right? So I mean, you don't have to have a fear that, oh no, I don't have an Intersect license, but the work I'm doing requires that I use Intersect. So literally, all you have to do is just launch and select what simulator you have to use, and all of this will be controlled by your subscription. And then once your run is complete, without you even noticing, your results will go back into your computer or into Petrol without you having to download it. So there's zero manual work that needs to be done. So this solution basically means that you are not controlled by software. And I'll keep mentioning this because it's true. You're not controlled by software restrictions and you're not controlled by hardware restrictions. What drives this is the activity as well as the operations that you're currently doing, right? So, I mean, if there's times where you don't need to use a lot of simulation power, I mean, you can just use the little bit that you need. And then when there's times where you have intense studies that you're performing, then it means that you'll be able to take advantage of more, right? Of more software and of more hardware. So this solution is provisioned instantly. And what I mean by that is, you don't have to worry about installing a virtual machine. You don't have to worry about installing, various software and plugins, etc. All you have to do is just create a little queue inside Petrol and you can just easily launch that, right? And then when you're done running, you can stop. You don't need to go back and forth doing a lot of manual work. Yes, I mean, as I mentioned, this is elastic. So you're able to use as much resources as you need for the work that you're doing because after all, it's on demand, right? And when we speak of on demand, it means that you use something when you need it for what you need, for what you need it for. Right. So these are the pillars basically around reservoir engineering, ODRS, or around what ODRS has been built on, right? The first thing is that it is highly accessible. So whether you're at home or whether you're at the office or even in the field, right, you're able to access this. You're able to launch your simulations to ODRS, either using your on-prem modeling software or using the Petrotechnical suite set of software that we have available for you in the cloud. Okay, it is highly scalable, right? So if you're in a situation where you need to use a lot of parallel power, you're able to access that and there is no limitations, right? In addition to that, I mean, the user experience is very simplified. I mean, you don't expect to have a lot of disruption, right? Because, I mean, you work in Petrol, you launch your simulations to Eclipse, right? The only difference is that it's going to a different place, which is in the cloud. So you don't expect to, I mean, you won't be frustrated in terms of, having to change the way you're working. It will be the same. The difference will be where your simulations will be run. And lastly, the solution is highly automated, right? So you don't have to worry about, installing things, worrying about what you need to configure, etc., right? It's instantly provisioned, and the data transfer to and from the cloud is automatic. It's something you don't have to worry about. So, I mean, this slide, of course, is just repeating the ideas that I've been mentioning. I mean, how can you access the service, right? Or how can you launch your simulations to ODRS? So we can do it in two ways. I mean, I've mentioned this. You can do it from the DELFI environment using the Petrotechnical suite, or you can do it using the local environment, which is basically your computer, right? In the local environment, you're able to do it through Petrol Reservoir Engineering, right? So if you've built your case and you're ready to run it, all you go is to define simulation case, select the DELFI queue and click on run, and your simulation will go into the cloud. The second way to do this is through the command line. I mean, because there's some people who might have their models currently in Eclipse text files or Intersect, right? So what this enables you to do is to launch those using a command line, into the cloud without having first converted your models to Petrol. So of course, another way to do this is through third-party software, right? I mean, if you have your own software that you're developing internally, or if you're using competitor modeling software, you do still have access to ODRS. You are able to launch this into the cloud, and your results will come back the very same way they would if you were to be using Petro Reservoir Engineering. And finally, you're able to launch your simulations from Meeple, which is basically our dedicated software for uncertainty and optimization studies. So this ODRS service comes with the simulation monitoring tool, right? So this is basically a facility which allows you to keep track of your simulations, right, as they are running in the cloud, right? So I just need to mention the fact that, I mean, you're able to access this using your cell phone, you can use a tablet, you can use a laptop, and you can use a computer. No matter where you are, you're able to just log in and see the status of your simulation. So this basically gives you the facilities to be able to manage your jobs, right? So you're able to scroll down to your case of interest, right, to see how it's progressing. I mean, do you have any errors? Are there any warning messages that you're getting from the simulator regarding data that you need to change? So all of that can be seen here. In addition to that, I mean, you know that when you run Eclipse and Intersect, we normally have a console window, right, which just shows you the progress of your simulation. It tells you how is your pressure dropping, what is your production at a particular date, right? So that will also be available for you to see, right, as you're running ODRS. So you have access to your console window. And you also, lastly, have access to your print file, which you can download from the cloud. And you're able to visualize it the very same way you would if you were to be running your simulation from on-prem Petrol and Intersect. So of course, I mean, it's one thing to just talk about software and technologies and tell you how wonderful they are, right? But I have some stories that I'd like to share with you, right? Which is just examples of instances where our clients made use of the service and it made a considerable difference to the way they work, right? So the first client is one that is based in Australia. So this client had, work that they would normally complete in 6 months, right? A 6-month project, which through using ODRS and Delphi, they were able to complete that in just a week. I mean, can you imagine? Like, so from 6 months to a week. And this is because they were able to access our high performance computing where they made use of thousands and thousands of, sorry, they ran thousands and thousands of simulators using however many processes they needed, right, to complete this. And this client actually took advantage of our entire Delphi offering, right? And they eventually uploaded all the information and data into Delphi. And this evolved into what we call a living model, right? So the model is in the cloud, and on a regular basis, they're able to continuously update the information that is contained in the model. So another example is that of a client in Scandinavia. So this client basically was able to minimize 40 days of simulation work to just 24 hours. Okay, and this happened because they were able to access, for each run, at least 64 cores. And this amounted to about 500 simulations. And yes, they were able to complete everything in just one day. So another client is one based in South America, who was able to reduce 4 months of work that they normally perform around risk assessment to just 3 hours. Okay, and our biggest one yet is a client in Saudi Arabia who basically took advantage of Delphi to run the simulations, right? So this was a very, very, very big compositional model, which I think had about 500 million cells, right? And they had about 14 fluid components constituting their compositional model. So this client was able to run multiple realizations of the model using about 1,560 cores, which translated to about 8,000 concurrent cores. And they were able to do the study in a very, very short time. Right. So, I mean, what we can see and take away from these stories is that this solution actually works very well. It's unlimited. You can make use of however many resources you need. And as I mentioned already, you're able to access this from your home environment or from office, I mean, which is particularly useful for now because, I mean, I bet a lot of you guys are joining this call from the office, right? Sorry, from home, because most of us cannot go due to the current COVID situation we're in. So this is literally useful for you. So just to summarize on ODRS, right? So this solution is virtually unlimited, right? You have access to all the hardware and software that you need, right? And unlike the HPC, I mean, your clusters do have, a lot of cores, right? But the difference here is that they do not give you access to as many licenses as you need, right? And this is where ODRS has the upper hand. So in addition to this, it gives you flexibility in terms of where you can launch your simulations from, right? You can do it from both Delphi in the Petrotechnical suite, and you can do it from your local environment. This solution can be accessed remotely, right? So you don't have to be in your office. You can just launch to ODRS, and you can have confidence that your simulations will run, right? Unlike with HPC, where sometimes you may have issues with connectivity to your office. In addition to this, within the Delphi environment, we have enrichment of our workflows through the machine learning and analytics that are enabled. And this solution is fully supported by Schlumberger, right? So if you're working in Delphi and you encounter any issues, you can be confident that there will be a Schlumberger person ready on the other side 24/7 to help you out with whatever issues you may encounter. So just to give you a bit of a bigger picture in terms of how these solutions connect to each other. Okay, so with ODRS, as I mentioned, you're able to take advantage of the cloud from your local environment, right? And this works for both Schlumberger software as well as external software. So once you launch your simulations into our HPC environment, also from the Petrotechnical suite, your models will run, and valuable information from your model will be extracted, right? And it will be liberated into your data ecosystem, right? So in the background also, there'll be services which are activated, right? Which actually do take advantage of this data that you have sitting in this ecosystem. And you can use this for further analysis, right? I mean, the one was this RE Data Explorer that I just gave a little bit of a introduction into on some of the previous slides, which basically helps you to manage all the cases that you'll be running to get an overview on a high level of how each case is performing, right? Uh, I mean, no matter what you're using those cases for or what study you're using it for. As I mentioned, you're also able to push that further into data analytics, right? Where you're able to take advantage of our dashboard and visualization canvases, right? To plot these results and to make meaningful decisions. And what we're actually working on is another automated facility which helps you optimize where you can drill your well, right? So by creating maps that look like this, you're able to identify sweet spots in terms of where the optimal location would be to drill your well. Okay, just again on the Data Explorer. So this is part of the reservoir engineering workspace, right? And essentially what it is it is what is activated in the background by the data ecosystem, right? Once data becomes available from on-prem or from the Petrotechnical suite. And this constitutes of the Data Explorer and the analytics, right? So what you're able to do from here, I mean, as I mentioned already, is model management, and you're also able to collaborate with your team. And this works very fine because your team can see what you're doing without asking you or without interrupting you. I mean, if your manager wants to understand how the asset is performing or how a particular well is doing, they can just easily go into the Data Explorer, filter down to that particular case or study, and they'll be able to get the results that they need. So the Data Explorer, as I mentioned, works very closely with the data analytics, right? So this basically allows you to perform detailed analysis. I mean, we've spoken about this, right? And as you can see, there's a host of tools that you can use to visualize your data, right? So you can have a comparison of the production for all the different AFDP schemes you have, right? And this is for all the fluid phases that you have. You're able to plot all of these. So all of these are cases here for different development plans, right? So one, for example, could be a gas injection, one is water injection, and one is one where you have natural production, right? So you're able to see each of these cases and how they compare to each other and how they're performing. And you're also able to narrow that down on a well level, right? To see how each of the wells that you have in each of these plants are performing. One that I like as well is the fact that you're able to plot all of those cases, right? And then for each case, if you just click on a box, it opens up the preview of the model, right? So you're able to see how much hydrocarbon saturation you still have at a particular point in time. If you're injecting, you're able to see how water is moving within your reservoir. And all of this is enabled using or in the RE Data Explorer from data that is shared into your reservoir engineering, your data ecosystem. So with that, I would like to end the presentation. Sorry, I have one more slide. So this is just, again, the dashboard. I've just zoomed up for you so that you can see the different tools that we have. So you can use a histogram, you can use scatter plots, you can use line plots, right? Depending on what you want to visualize. And at the same time, you're able to scroll down or use filters, right? Suppose that you want to see fields that are producing above a particular cumulative barrel, right? Or cases that have a particular value of the critical saturation. You're able to scroll using these sliders over here, and these canvases are interactive, right? So whatever it is that you change here or on one plot will be reflected in the other plot, right? And all of this will help contribute to, helping you make meaningful decisions, which will contribute to your business in the long run. So yes, this is my final slide. So I will now hand over to Henio, who will take you through the demo, right, to demonstrate all of these functionalities that I've presented to you.
Okay. Good afternoon, everyone. And thank you very much, Ndivhuwo, for the nice detailed presentation. Please just confirm if you are able to see my screen and also the Petro project that I have open.
Yes, I can see.
Oh, okay, thank you very much. This is the Petro interface, and I'd like to show you from what the what Ndivhuwo has presented you. I'd like to show you the ODRS solution, which is the on-demand reservoir simulation, and how it enables you to work from home or from your office in your premise using your current uh, laptop or computer and submit your simulations to the cloud. So this is my Petro project open, and if you see is the normal Petro window within my machine, and I have here a project. So what I will do, I'll show you how to submit the presentation, the simulation into the cloud, and which workflow you need to follow. So if you go to the case pane, and we have here one intersect case, we shall go and open the defined simulation case. So from the defined simulation case, I will be able to set up the simulation the same way you do from your on-premise. But the difference here is if I'm running Intersect, for example, I'll go to Advanced tab and to the runtime environment. And instead of running normally locally, the same way you do if you're running in your current laptop or if you have a cluster available, you select the Delphi as a cluster in order to simulate. Now, just to show you, my laptop has a total of 12 processors available. And what I'll do now, within the Delphi environment, I will select the number of processors I will require to make my simulation to run. And since I have scalability to be able to increase the number of processors, so I will, for example, put here, I want to run this simulation with 32 processors. And I will define the Delphi code, which will allow it to submit this simulation into the cloud environment. And then once that is done, I'll just click on apply to make my settings and run the model. So if you see, as Ndivhuwo has just mentioning, the workflow is exactly the same. So you won't have to adjust or create a new workflow and do many setups once the program it is defined. And through this, he will submit your simulation into the cloud. Now, how do you are able to oversee and monitor your simulation? So you'll be able to do that by logging into your own personalized account within Delphi. If you see, you have an account defined for you in Delphi where you have your name and your setup defined. Only you have access through your account. And on this, you'll be able to select from the different workspace environment, you're able to select the on-demand reservoir simulation one. So this one is where you'll be allowed to monitor each simulation that you will be is submitting into the cloud. At this moment, I don't have any simulation because the one I'm creating is currently uploading. The uploading time to Delphi will be, of course, dependent of your network speed. Okay, so since the simulation is uploading, what I want to show you is this is used for one single run, and I want to show you the scalability of the on-demand reservoir simulation and the Delphi environment, as Ndivhuwo was mentioning. So what I'll do here, I will open a workflow in order to be able to submit uh, many simulations through uncertainty and optimization. So the workflow will be the same, opening the uncertainty and optimization tab. And I have already all my cases defined and also all my variables as well. And what I will do here, I will define the number of case samples. Since this is a demo, I will restrict the number, for example, for 15 cases I want to submit on the cloud. And with that, I will apply to make my case saved, and I'll test to make sure it is fine. And for the purpose of workflow, I will click run here from the workflow tab, and I'll select run. So what I did is I submit from my own laptop another 15 realizations of this specific model using uncertainty and optimization through UNO. And as you saw before, my laptop only has 12 cores, and I'm running this simulation and all this branch of simulation with much more than my machine is capable. Going back into my simulation, and on the reservoir simulation monitoring tool, as Ndivhuwo was mentioning, I can see that my simulation is already uploaded into the cloud with 32 processors, and is preparing the environment in order to simulation to start. And has the other uncertainty and optimization cases I have just created now starting to be uploaded into the DELFI environment, you'll be able to monitor these two. So while the data is uploading, I would like to show you how are you able to create cases using your simulation launcher, for example. So I'll open the simulation launcher the same way you may use it to run Eclipse or Intercept. And for this demo, we will see how to use the simulation launcher to run an Intercept case. So basically, the workflow will be the same. So we will add the dataset. I have here already one dataset created. I will add that. I will select the number of processors I want to run with this dataset. For example, here I'll say, okay, I want to run them with 32 processors. One very important thing is I have to define the queue system, and which is the DELFI environment. So what I'll do, I'll come to advanced, I'll enable, and I have to make sure I have this command here set, which is basically saying my queue system is the DELFI system. So with that set, I just click run, and I'll be able to run my simulation here with 32 processors using the cloud infrastructure and not my own machine. Another way to submit your cases is, for example, let's say you have an Intercept or an Eclipse model folder in your computer. So, and you can run it manually using the defined command line. So I have here this case. This is a folder which has an Intercept case. So what I'll do, I will add this simulation to the command line. I just type here CMD, and I open the command line. So I just type in the code, here run for Eclipse. I will define the queue system, the same one I have shown you before, equal to DELFI. I will define the number of processors I want to run this case, and for me it will be 32 again. I will define which simulator it is. In this case is Intercept, and I will put in the name of the case. And through that, I'll start to running my simulation into the cloud. So just a second here, okay, and I will submit it. All right. So if I go now into my simulation monitoring tool, you can see that the cases I have submitted to simulation are already uploaded into my DELFI environment. And as you can see here, the first one is already running, and the other ones from the uncertainty and the cases I run manually are already uploaded as well. So this tool will allow you to monitor all your simulation. So if I click on the first one, which is already running and finishing, I'm able to see in detail the number of warnings, problems, or if your simulation has any error. Furthermore, as Ndivhuwo was mentioning, it will run with the latest interset version. So all the bugs and errors that have been corrected with the new versions will be automatically be the simulator with all these corrections and fixings, which will be running your case. This will not impact your data file neither from Eclipse or Interset, although you'll be always updated to the latest version of the simulation available when you're running through the DELFI, even though you don't have that installed in your machine. And you can see here the same black box which we monitor when we are running a simulation locally, and you can see it, the status of your simulation. For now, this simulation here is already finished. It is completed, and I can see that it ran properly without any errors or problem. Okay, so also I can go back up and I can download the print file corresponded to the case that I'm running. And then here, I can monitor the print file, how simulation is ongoing, and understand how is the conversions, the time step, and everything. So I have control throughout the simulations, even though I'm running through the DELFI environment, and I can manage them. So if I go back to the reservoir simulation monitoring tool, and adjust here to see all the cases that I have. So some of them are being prepared in the environment, some of them are already start running, and you see some cases, one case for now, it is already completed. One important thing in this tool is that you are able to monitor and filter out the cases. You can filter by name. For example, I have here the case which I did through the simulation launcher. I can easily go to this case and filter out. So if you are running 200 cases, you have an easy way to monitor your runs through the name. You can also filter them through the submit date, the model, if it is Eclipse or Interset, the number of processors you are using. You can also oversee that, number of threads of your simulation, the progress of each one, and the status. So for example, I want to see all the cases that are running right now, so I can easily quickly filter out the cases that I still prepare in the environment so that it will start run soon, and the cases that have already completed at the moment, which is one at the moment. See, so you have easy control of the cases that you have submitted to run. And once the simulation is run and completed, it will automatically be downloaded back into your computer and your project. So in this case, I will go back to Petro, and I'll see here the first case I have submitted is already completed, and I have my simulation results. So let's visualize that. I'll open here the charter window, and I'll be able to select the case I have just run, and I have here my simulation results. If you want to see in detail, you can do a right click and open the case folder, and you find out how the resulted simulation files are here stored in your machine. So that means your data is back into your laptop, and no data is stored in the cloud. And this is the beauty of on-demand reservoir simulation because your data will not be residing in the cloud. You'll be only able to upload, make the simulation, and download. So the first case is not here anymore, and you are not able to retrieve it because the data is already in your machine safely, and there is no record on the cloud that this simulation was run. So this also gives you a further additional security that the normal DELFI environment provides and the cloud environment provides. So with that, we turn to the Petro project, and I will expand here and to be able to monitor all the cases from Petro, the ones that have already started running, and I can easily see the percentage of this case and how far are they to finish. Okay, so there is a direct link within Petro and the cloud on the simulation status. So since the simulation is undergoing, and for the purpose of time, I would like to show you how are we able to manage all this data once it completes running using the Reservoir Engineer workspace as Ndivhuwo was mentioning. So through this, I will open here and show you this demo video, which is the same thing. And here I have the DELFI environment from the Petrotechnical suite, as Ndivhuwo was mentioning, where you have all the simulator available in the cloud. So you're able to open Petro in the cloud and do the same workflows that I have done, from creating a project, running a models, submitting cases. So the difference here from the PTS is that you will be only using the DELFI and not your local machine to perform exactly the same workflow as we have seen it. But let's say you submit, for example, 200 cases of simulation. How fast can you digest this data? How fast can you analyze it? And this is the RE workspace, and this is where all your simulation information will be stored. You can filter it through the date it was created, the user, and you can see the results of each specific simulation model. So in here, we are selecting, for example, different branches and assemblies of cases, and I can quickly do analyzing and clusters from all the simulation. So from here, an example, I'm seeing the distribution of all the different three different uncertainty scenarios I have created. I can see how is it impacting in terms of the production rates, cumulatives, and so on. Beyond that, I can go to a specific assemble or uncertainty case and visualize oil, gas rate, for example. I can visualize the ratios and also the water cut. So I can quickly use all the data and all the simulation information, and with support of the data ecosystem from the DELFI environment, I can quickly create clusters and filter and get decision making from these cases. So through that, it can allow me to filter, identify, and select scenarios which are candidates for further field development. So this is an example of how the RE workspace it is. And the value is that we're able to connect and work not in silos. You are able to share the data and your work in collaboration with your team, and you're able to use all your simulations to additional DELFI platforms, which is FDPlan, as you can see here. So through this, let me go back to my simulation cases, and you can see I only have 3 now. So which means all the other cases that I have submitted to run have already completed running, have already been downloaded, and once they start disappearing means the case is already in my deck. Now most of the cases are run and they are already in my project. So I can go back and I have all my cases here, and I can easily select them and see the simulation results. So let me open, and through that, select the multiple realizations I have created and visualize its result. So as you could see, in my machine with 32, with 12 processors, I was able to run in less than 20 minutes more than 15 cases, and be able to do uncertainty and optimization scenarios with the 32-way processors, 16-way processors, and have the result back to me, and now I'm able to do analysis through this. So this is the DELFI environment. This is the value it gives to us. And through this, I'd like to finish this demo and open up for questions that you may have on the DELFI environment, the ODRS, which I just present to you in detail, and the RE workspace if you have questions on that. Thank you very much. I would like to mention that our next session will be on the interset overview, and we are working on the recordings, so those will be available for you so that you can follow not only the session topic to come, but how that were done before. So we'll share the link once we have the complete process set up. And if there is no questions from the audience, I would greatly like to thank you for attending this session and tell you that the future is today, and with the current trend the industry is going, especially speeding up through the COVID to the pandemic situation, is embracing the digital pathway. So these solutions we have presented to you today are widely available, and I have just shown you from my machine working at home that it really works, and we're able to expand, scale your simulation wherever you are, and no compromising timing, and be able to adapt to the lean and fast process that the industry is undergoing. So if you require or need any further assistance or detailed explanation about the digital environment, we are available to you, and let us know or send us an email. If there is no additional inputs, I would gladly thank you for your time, and I look forward to see you in the next session. Thank you very much, Ndivhuwo, for the great presentation done.
And thank you very much, Henio, for the wonderful demo.